Okay, so we're going here today. Hopefully, those of you on Zoom, I guess let me know, but I was supposed to have a new computer prior to the start of the semester. I finally got it yesterday, and I played around a little bit. This should sound a lot clearer. I probably won't, if I'm talking too loud now for it, let me know, but I know that just from kind of playing around with it a little bit yesterday, it came in a lot clearer as I was recording, so hopefully that is the case. Yeah, sounds better. Okay. Yeah, I'm glad. I think it sounds quite a bit better than it did before. All right. So we left off last class. We worked through kind of variances, standard deviations. So what we're going to do today is talk through weighted means. Oh, you guys in class here are seeing what you're supposed to do. So we talked about how we find means. There we go. Here I'm problem in class. So we talked about how to find means, which if we only have group data, so for example, let's say, some of the data we'll look at, I had this huge data set, but you couldn't see it, right? And it had like 100,000 different people and their income values. But the only data that I'm going to give you, because I don't want you to be able to identify like these people and how much they make, is I'm going to tell you how many people in the data set make between $10,000 and $20,000. Right? Sorry, I'm going to tell you the average income of people who are in between, say, 20 and 30 years old. Right? And then I'll also give you the average income of everyone in the data set who is between 30 and 40 years old. So I'm not giving you the original data, I'm giving you some group data, right? Make sure everyone's in here. So if all we have is this group data, well, if some groups are larger than others, we can't simply treat them the same, right? So I'll kind of show you in a second, once we look at the equation for weighted means and relate it to what we were doing with means before. So the example would kind of be if I'm trying to do like the average fast food sales, even in a town like Muncie, right? And I know that, and all I can see is the average food sales by company. So I see what the average McDonald's sells in Muncie. Well, there's several McDonald's, right? And I see the average food sales of Berkey's. Well, there's only one. So I shouldn't be treating those equally. One of them should be weighted more because the McDonald's observation represents, I don't know, 4 McDonald's or however many there are in Muncie. There's like 5 Pizza Kings, so I don't, but so the idea is we have different groups that represent a higher number of observations. We want to weight them more. So what we're going to do is in this group data, and we'll walk through some data sets in a second, so I think this equation will make a little more sense. For each group, we're going to take the value they have for whatever variable we're interested in, right? So this might be like the average income for people between 20 and 30 years old, and then multiply it by the weight or how many 20 to 30-year-olds we had in the data set. I then would go to the next age group. How many people were between 30 and 40? What was their average income? Multiplied by the number of people between 30 and 40. Continue to do this for every single different age group. And then add them all up and divide by the sum of all the weights. Right? And the sum of the weights there would be just adding up the number of people from every single age group. Okay? So I'll give you a couple more examples here in just a second. So the steps are going to be go through each group, multiply the value of the variable you're interested in by that group's weight, add up all those products, right? The value times the weight, add them all up, then add all up the weights together. You'll have the numerator, you'll have the denominator, so then it's just a matter of dividing that numerator by the denominator, right? Add up those products, that's your numerator, add up all the weights, that's your denominator, divide the sum of those products by the sum of the weights, and you'll get your weighted mean. Okay, so we'll work through an example here, and then I'll kind of go. I want to draw something out for you guys. So let's say I have male and female income, and I have it by different 4 different racial groups. Right? So obviously this isn't like comprehensive, but if you go to pull the data from the U.S. Census Bureau, This is actually where I pulled this data from. They won't give you individual level data, but you can get it grouped by gender, race, region of the country, age. So here I just kind of pulled this out because it makes a good point. So I've got 4 different groups. notice the number of people in each one of these groups, the kind of white males here is a much larger, has a lot more observations represented by one value here. This is group data, right? The original data had individuals and their incomes. This group data, all we see is one income value for this entire group. And it represents 73,000 versus like 6,000 down here. So the process that which we'll go through is take the value of the variable we're interested in, so income 59,000, multiply it by that group's weight, so 73,000, then add to that 38,000 times 11,000, add to that 60 times 6,000, add to that 36 times 17. When we add all those up, that'll be our numerator. Our denominator would just be the sum of the weights here, right? And the sum of the weights I happen to put up here, if we add all these up, is 108,000. So if I typed all that out, it would look something like this, right? Take the value for the first group, 59,000 times the weight, so 59 times 73,000, add to that, 38 times 11,000, so on and so forth. Divide by the sum of the weights, which would just be adding up these guys right here. Okay. So we can find the weighted mean for kind of male income here. We could do the exact same thing for females, right? And I put that value up here. I won't walk through it in class, but you could try to recreate it on your own. Might be some good practice. It's just that you would have different weights and different income values, right? But it'd be the same exact process. You would go through 34 times 75,000, 28,000 times 14,000. Do that for each group, add them all up, and then divide by the sum of the weights there, or kind of the sum of the number of people in each group. Okay? So the whole reason we do this, oops. I'll come back here in a second. There we go. And then I gotta get there. Okay. So the whole reason we do this is if we think about what we were doing with the original mean. Right? This is our original equation for the mean. We said another way to think about this sum, it's really just x1 plus x2 plus x3 divided by n. Well, if everything's being divided by n, we can actually rewrite this as x1 over n, x2 over n, x3 over n, etc. And another way to think about this is if I divide by anything, it's the same as multiplying by 1 over that. And so if I look at it this way, and I think about it, I was really finding a weighted mean before. If 1 over n was my weight, it's just that my weights for every single number was exactly the same. So if I sum up the weights times the x's, but the weights I'm using are 1 over n, right? When I divide by the sum of the weights, 1 over n for n observations, so this is going to kind of like 1 over n added to itself n times 1 over n is going to go away. And kind of the 1 over n here, if I sum it up, I could pull it out here, it's really just going to be the sum of the x's over n. So like that's how, you know, you can kind of prove this mathematically, but really what we were doing before was weighting everything just as 1 over the total number of observations. Now it's a little bit different, right? Now we've got sum of the weights times the x's divided by the sum of the weights. But here we can think about each group is not now just 1 out of n number of observations. It is whatever the weight of that group is out of the sum of those weights, right? Or out of kind of the sum of those weights you could think about as that was the n in the data set that you couldn't actually observe. That was the n in the data set that was pushed or forced into this group data. Okay? So another way to think about this is you could kind of think about, here's the sum of my weights. Each one of these is, say, W1 x1 divided by the sum of the weights plus W2 x2 divided by the sum of the weights, etc. So you can kind of see here, what we're really doing is the weight that this is getting multiplied by is the proportion of whatever that group makes up of the data. So in the data we were looking at, it was like 73,000 white males, and the total was like 108,000. So the sum of the weights was 108,000. The weight of that first group was 73. But really what you're doing there is this represents the proportion of all the observations that came from that group. Right? So it's kind of hiding behind the scenes there in that weighted mean equation. Right? Just kind of trying to compare that to what we were doing before to hopefully make a little more sense, right? Like now, not everything should have the same weight because it's not 1 out of n, it's w out of, and really the sum of these weights here we can think about as representing n. Okay. Any questions on any of that before we kind of keep moving through stuff here and look at the chat? Okay. Okay. So I now go to switch this guy, switch it for us here in class. Should kick over here in a second. There we go. And then we'll share the screen. There we go. All right. So now that we kind of, just thinking a little bit more about what this weighted mean is doing, kind of can see here, if I look at these values, right? Actually, I'm going to show you something in Excel here. Oh, I wasn't supposed to do that. Why isn't it like that? Having technical difficulties here. Give me 1 second. I think you guys on Zoom can see, yeah, you guys are seeing what I want you to see, but in class I'm not getting it to. There we go. So I want to take this data that we calculated that 53,000 mean from, and I'm just going to do real quick in Excel, if I just treated this like a regular mean, right? So I don't use the weights, I would have found 48,000. So why is the weighted mean so much different? Well, if I look at this, what value is going to be influencing that weighted mean the most? The one that has the value that comes from the group that has the highest weight. So this weight is so much higher that 59,000 is going to pull that weighted mean up a lot more than the 38 and 36 are going to pull it down because those two groups have much, much lower weights, right? So if I look at this data, whoops, I didn't want to show you all the values ahead of time, but which region should be influencing the weighted mean the most here? So if I look at these different regions, so instead of having it broken down by race, I've got this broken down by region. Which one of these regions' income should be influencing the weighted mean the most? Yeah, the South, right? It has easily the highest, it represents the highest number of people, so it's going to have the highest weight, which means it will influence the weighted mean the most. And which one would influence it the least? Looks like the Northeast here has kind of the lowest weight. So we can kind of think about, here these numbers are pretty close together, so it's a little bit kind of harder to think about. I mean, how much different is 37 than 35,000 weighting, but that's still, the idea would still hold. All right, and I'll switch this over to the webcam down here in the corner. I didn't realize I'd left that. So if we can do a weighted mean, we can do a weighted variance as well, right? It's the exact same process. Well, it's very similar process to the variance with adding in just one additional thing, which is we're still going to be taking the deviations from the mean squared, but now once we find those deviations from the mean squared, well, those deviations only matter if they represent a large number of observations, so they only matter if they have a high weight, right? So now we have to take those deviations squared, multiply them by the weight of that group, okay? Once we do that for every single group, we add them all up, and then we'll divide by, here I put n, the total number of observations. But what I already said earlier, we can kind of think about the total number of observations in that original data set before it was grouped. That's going to represent the same thing as the sum of our weights, right? So here we could replace n with the sum of the weights, and it'd be the same thing, okay? So I kind of pulled that male income data again, just to kind of show you how we would find the variance. So I have this additional column, so I'm going to do a little bit more. I'm just going to show you this in Excel too, because I think it's a nice, easy way to see it. So the way I got these values is I went through each observation. I took the value for the X variable, so 59,000. I subtracted the mean, which we found earlier was like 53,200. Whatever that difference was, I squared it, and then I multiplied that by 73,000, wrote that number down, right? If I did that for every single observation, I then added them all up, divided by the sum of my weights, which represent n, and I should get this 94 million here. I'll walk you through it a little bit more step by step here, kind of in Excel, to kind of show you what I was doing, and also to give you an idea about how you could do this in Excel. So all I did was copy and paste the data there. So I'm going to try to recreate these numbers. Right? So I've got my weights here. I've got my variable X, which was income. So what I want to do is find the weight times the deviation from the mean squared, right? That's what I want to try to find in this column. Well, just ahead of time, I'm going to know that I need to use the mean. So what do we find? I think it was 53,296, it looks like. So 53,296, right? So for this cell, I'll say, okay, look, take the weight of this group, multiply that by the X variable minus the mean squared, right? So take that deviation, square it, and then multiply it by the weight.
Don't you want to freeze the,
Yes. So what's going to be the problem if I try to copy this down? Well, I always want to subtract the mean, so I need to freeze this cell, right? Yeah. Jumped ahead of me there. I was going to show you that, but yeah. We need to freeze that because, well, I'll show you. If I don't freeze it, it'll use this, which treats it as 0, right? So you subtract 0 from whatever value you have, which ends up giving you much larger numbers here that aren't correct. So we'll freeze it and copy this down, okay? So once I have these values, the next step is I need to add them all up. Well, if we want to do this in Excel, it's pretty easy to just equal sum. If you're in a calculator and you wrote down these intermediate numbers, you would just add these numbers on. Now, these are really big numbers, so it's kind of a pain in a calculator to like type these in, you know, which is why I'm showing you how to do it in Excel instead of writing them all down. But you could, you could do this in a calculator like a T83 or something. You could have just entered all of this in, right? And then at the end hit enter, and you wouldn't have seen any of these intermediate numbers either, but it's, whatever you kind of find easiest. So I hit enter. That gives me my numerator. I can actually do one more thing. So I need to take that numerator and divide it by the sum of the weights. So here I can divide it by the sum of these weights. And I can do that all in one cell, hit enter, and it gives me that 94 million. All right. Now notice here, with the weighted variance, we said observations that are really far from the mean, that should add a lot to the variance. But now we have an additional component. If it's really far from the mean, it shouldn't add as much to that numerator of the variance if its weight is low. So notice 59 and 60 are both pretty far from that mean of 53. But for that group that's really far away, because the weight of that group is low, it adds a lot less to the variance than this group that's a little bit closer to the mean, but they have a really, really high weight, right? So kind of two factors are now kind of being built into that, how much an observation adds to the numerator of that variance. Okay? Any questions on this before we keep moving? Let's see if there's anything in the chat. Okay? So we kind of play around with this in Excel. The other thing I wanted to show you before we keep moving here, because I think it's kind of interesting. So I'm not going to go expect you to do this equation or know how to use it, but I'll just kind of describe it to you just so you can kind of see. So what's in this cell is there's this formula called, I move myself. There's this formula called average ifs. And so what you do is you say, okay, what do I want to find? Maybe I want to find the average GPA for all the women in this data set, all females in this data set, and I want to find the average GPA down here for every male in this data set. Well, all the way over here, I've got that GPA variable. So I tell Excel, okay, look at that GPA variable. And then the next thing I tell, so comma, then look at the female variable. So what I want you to do is take the average of what the first variable I told you, only if this second variable is equal to 1. So what Excel is essentially doing is it's looking through that female variable. Every time it sees a 1, that represents that it was a female. It pulls that observation out, puts it in like a temporary data set, and then once it's gone through every observation, now in this temporary data set has only the GPAs of the females. It takes the average of it and tells it to you. Right? So I have the average female and average kind of male GPA here. I then wanted to, okay, if I'm going to find a weighted mean, like if I have this grouped data, here it's not as many groups, it's only 2, but I still have group data, right? I know the average GPA for both of these groups. Well, if I want the weights or the number of people in each group, I can use that count if formula, kind of like the count ifs we talked about, but it only has one criteria. So here I'll count how many observations. So I'll look at this female variable and count it only if it's equal to 1. So it'll count the number of times I see a 1 for this female variable, which essentially is going to tell me the number of females in the data set. I then go do the same thing. How many zeros do I see in that female variable? Every time I see a 0, it represents, I mean, I guess here we're forcing somewhat the gender to be binary, but for the sake of this example, right? If it's 0, then we'll kind of classify it as a male, all right? So I've now got my weights. I've got my variable X of GPA. What did I do in this cell? Okay, I'll show you in just a second. I'm going to recreate this. So if I want to find a weighted mean, I'll take each group, I'll take the weight for that group times the average I see for that group, for the variable I'm interested in, plus the weight of the next group times the average of the variable I'm interested in for that group. That's going to represent my, oh, I didn't want to do that. Stop. That's my numerator. I'll then want to divide that by the sum of my weights, which are over here. Now this should give me my weighted mean, right? So I've got my weighted mean right here. But notice, if I find the weighted mean of this group data, here I kind of forced it into these groups, but I still have the original data. So if I take the average or the mean of this original variable, let's see what happens. If I take the average of the original variable or the original data that I saw before it was forced into these groups of male and female, I'll get the exact same thing, right? So the weighted mean will give us the same value as if we had the original data, right? Even though we don't. Now, if we already had the original data, there's no reason to put it into groups and then find the weighted mean. I'm just kind of using this to show you that that's the case, all right? So we'll kind of go back here. I had a couple other examples. So hopefully we walked through how to do that weighted variance. Once again, I put up what the value would be for females, so you could go through, get some practice, try to recreate that on your own. Whether you do that with a calculator, you could do it in Excel, kind of play around with, these frequencies and these values and try to recreate that 15 million, right? So how would you do that? You would take the first of all, you go back, have that 32,000 was the mean female income. So take the value for this group, 34,000 minus that $32,000 mean, square it, multiply it by the weight of that group, write that number down, 28,000 minus 32,000, square it, times the weight of that group, write that number down, do that for every group, add them all up, and divide by the sum of your weights here, and you should be able to reproduce that 15 million. Okay? So this data is interesting. It kind of shows kind of racial and gender disparity in income. But also it's something interesting that comes out of, we can see in the averages that occurs. But notice the variance as well. If I just look at these numbers, 60, 59, 38, 36, there's a lot more variation, even if I just think about the range of these values, than if I look at 34, 28, 39 to 24, right? So just looking at these values, I can kind of see there's less variation in the data, and sure enough, that variance of 15 million, whoops, is much lower than that 94 million. I can even take it a step further. If I look at when I had it broken down by region, if I calculate those variances, look, these are a lot closer to each other. And so now the variances aren't even as high as 1 million in either of these, either gender. Right? So when the data is less varied, we should be getting kind of these lower variance amounts. Right? Now, in your homework and things like that, I won't be giving you examples like this. This is a little bit of a pain because income values are high, right? So when I start squaring things, that's why I was getting like what? I'm getting crazy large numbers, right? So I'm not going to give you an example like that on a test or something where the intermediate values are going to be this high. But I thought this was kind of interesting. It was real data I grabbed from the census. Kind of gives us an idea about some differences across race and gender. Okay. Any questions before we kind of move on? I got one more thing that we're going to kind of work through and point to. It's very similar to what we just did, but a little bit different. No questions? See the chat. Okay. So what if instead we had this data where we have a variable we're interested in? So maybe I want the mean satisfaction ranking of some product. So apparently people could rank it between 36 and 50. Doesn't really matter which one's highest or lowest for the sake of what we're going to do. But they only give me the data not as what every individual responded as. They only give me the information that, well, 4 people responded with either a 36, a 37, or 38. 15 people responded with either a 39, a 40, or a 41. 25 people responded, so on and so forth, right? So I actually now have bins. This is essentially what we did with histograms. It's like if I had a data set, I didn't want to share it to you because maybe it's confidentiality of the people that were involved in it. So I kind of create a histogram, and those columns I use to get the data to graph the histogram, that's all I give you, right? There's this many people in this bin. There's this many people in this bin, but the bin has ranges of values that it was counting. So if that's the case, how can we find a weighted mean using this information? Or is there anything we can say about it? Well, first of all, it works very similar as the weighted mean. It's almost the same thing, a little bit of difference in notation. So to find the mean, now my weights will always be frequencies, okay? My weights will always be frequencies. And I might do another example of a weighted mean before we get out of class to show you that sometimes when we're dealing with just a weighted mean, the weights aren't always like the number of people in a certain category. It could be something like the amount of money invested in a certain stock, right? The weights don't necessarily have to be frequencies when we're dealing with just a weighted mean. But we're dealing with these group data that kind of represents a range of values with these bins. We'll always have our weights being the frequencies, okay? So there, instead of weights, we're just using frequencies, the same idea. And instead of the variable X having a value, like for each racial or region group, we had one income value. Now we have a range. So what we're going to do is use the midpoint. So here, for this group, the value that they would have for the variable I'm interested in would be 37, 40, 43, 46, and then 49. So I'll use the midpoints and I'll use these frequencies, but now I do it just like I did the weighted mean. 37 times 4 plus 40 times 15 plus 43 times 25, so on and so forth. Once I add all those up, I then divide by the sum of my frequencies, right? So I divide by the sum of my frequencies. So it's the exact same process as what we did with the weighted mean. The only real difference there was we had to use the midpoint. So that was the only tricky part, okay? Now, I want to start writing this, showing you the other way we can write this as well, because remember I said the sum of the frequencies should be the number of observations we originally had in the data set. In fact, I can prove that to you really quickly. I know we only have 2 groups here, but if I add up my frequencies, and then I go back to the original data, remember we can use this count function and it'll just tell me the total number of observations in my data set. Oh, what did I hit? Oh, I hit my FN key instead of control. Oh, why is it not liking that? Oh, it's using column N. Hold on. Count. Control Shift, down arrow, enter. There we go. I get, right, the sum of my weights is exactly equal to the total number of observations, right? So that's why we can write that the sum of the frequencies down here is the same as N. Right? That's kind of where that's coming from. Okay? Now, we can also do a variance for this. It's going to look also very similar to the weighted variance. Well, now instead of using the variable X, we have the midpoint of each bin that we have information on. We'll subtract from that midpoint whatever weighted kind of mean we find here, square that deviation, and then now instead of multiplying it by a weight, well, our weights are just always frequencies, so it's still the same thing, but now we multiply by the frequency. Right? Once again, in the denominator, we're still going to divide by the sum of the frequencies, but because it's sample data now, we can think of it as n minus 1 or the sum of the frequencies minus 1. So remember, n and the sum of the frequencies are the same thing. So instead of n minus 1 here, I really could use the sum of the frequencies minus 1. Either way, okay? And the reason why it's n minus 1 or the sum of the frequencies minus 1 is because we went from having population data with the income data to now we have maybe kind of this, just a sample data set, right? This wasn't every single consumer. This was only 65 of them if we count these up, okay? So what will the process for each one look like? So for that mean, I kind of already explained this in words, but just looking at the values, I go through, I find 37 times 4, write that number down, right? The sum of that midpoint times the frequency, sorry, the product of that midpoint times the frequency. Next observation, or next group, 40, the midpoint times 15, the frequency is 600. I continue to do that for every single group. Once I'm done, I add up all those products. Right? I get 2,795. So that's my numerator. I then divide by n, or n representing the sum of my frequencies, which is 65. And I get that the mean is exactly 43. Okay? Any questions on this at this point? Let's pull up the chat real quick. Okay? Questions? So that's kind of the process, you know, and you can do this, like I'm showing you these columns because sometimes it is helpful, especially when you're doing this by hand and with a calculator, to write down these like intermediate values, like just so you can like do this line by line, then add them all up afterwards. So you don't have to put it all in your calculator at once, which, because if you do it all at once, sometimes it's easier to make a mistake, right? So for some people that they start, you know, I know what I'm doing, but you know, I always make mistakes in the calculator, or maybe I forget a parentheses. Doing it this way kind of helps you and kind of prevents you from maybe making some of those like small mistakes, okay? If we wanted to do the variance, we could set up a very similar thing. We set up an additional column. We go through. Now we look at the midpoint. We still subtract the mean. Take that deviation from the mean, square it, multiply it by the frequency. Remember our mean we just found was what, 43? So for the first observation, I take the midpoint of 37, minus 43 would be negative 6. I square that, I get 36, multiply it by the frequency for this group, which is 4, I get 144. I then go out and do that process for every single observation. Once I'm done, I add them all up, I get 522. Now this is where, because it's a sample kind of weighted variance, we divide by the sum of the frequencies minus 1. Or n minus 1. So we divide by that 522 by 64, or 65 minus 1. Okay? And that's how we get the weighted variance. Now, the weighted variance has the same properties as a regular variance in that, how did I get a standard deviation once I had a variance? All I had to do was, anyone remember?
Oh, square root.
Yeah, one more step, I take the square root. That's it. It's the only difference. We're just scaling the variance. So with a weighted variance, same thing. If I wanted a weighted standard deviation, the only additional step I do is take the square root of this, okay? So that should be pretty easy to remember that, right? Because it's the same as the original variance. Now, one thing I wanted to point out here is, notice this value here, 43 was the midpoint. It was exactly equal to the mean. So that's evidence that there's literally no variation in the data set. So 43 minus 43 is 0 times anything is 0. So notice it adds 0 to that numerator because it was exactly the mean, right? It was that group data was evidence that these observations show no variance. But the other groups, right, do show that there's some variation in the data set, okay? Because those were not equal to that mean. Okay? I want to mention something else. What was it? Endpoints, frequency. No, that was it. I think for this. Does anybody have any questions kind of over any of that? The weighted variance, weighted mean, kind of using these midpoints. We got time. We got quite a bit. Okay with that? Okay. So one other thing I wanted to do, I'll show you how you could set up one like this. So let's say I'm going to copy this just so I can show you in Excel. So if you are wanting to start to think about, and this isn't on your Excel assignment or anything, but if you want to start to think about how you could do this in Excel and set it up to be pretty easy, right? If I wanted to do that mean, let's say I want to do it for females here. So I'm going to go over here. All I have to do, right, the weighted mean was just take that weight, multiply it by the value for that group. So I do that. I then do that for every single observation. I then add them up, so I can use that equal sum function to add them up. Oh, wait, I wasn't supposed to copy this. These are the totals. Sorry, we only had 4 different racial groups. So I do that for every single group. I then add those up. That's my numerator. I can do this all in the same cell, or I can do it in a, I could say this is sum of x times w, sum of w. So the sum of the weights, I can just add these up. And then the final step is dividing the numerator by this denominator. So my weighted variance, no, not my weighted variance, my weighted mean is the numerator divided by the denominator, or 22,330. Right? Any questions on that? No? So it's kind of a nice and easy way to set up the weighted mean there. And then that also allows you to now pretty easily set the weighted variance. We kind of already did this with the other problem, but I'm going to take my weight, I'm going to multiply that by the value I see for that group minus the weighted mean that I found down here, squared. Once again, let's not forget, we don't want that mean value, that cell reference to change, so we put dollar signs around that, just like we did before. We'll hit enter. I'll then copy this down for each different region or each group. Right? Now I need to find kind of the sum of not just x times w. This is now, if I wanted to put kind of or labels on this side that represent this other column, sum of w times x minus mean squared, right? So I would add those up. That's a sum of all of those. I still need the sum of my weights. It's going to be the same thing. I don't really have to find it. I guess I technically don't need to find that one again, right? It's gonna be the same value as I had over here. But just kind of nice and easy to set this up. So now that I just take my numerator of that weighted variance equation, divide it by the denominator, which I don't know why it's doing this to me. It doesn't do it with my office computer, but I9. And sure enough, I get that weighted variance. I believe this is actually a number that I had in the slide there. Right. So, we can set this up, relatively quickly and kind of easily in Excel. I think it's a lot easier to do it this way than it is with a calculator, but teach their own, right? Like it's, either way is going to give us the same answer if we do it correctly. Okay. Some of the trickier stuff in Excel is remembering things like, oh yeah, oops, sorry, where was that? I need to put dollar signs so that it keeps using me. Like you might make mistakes like that in Excel that you might not make on a calculator, but you can set this up pretty quickly and easily, and not worry about typing in these big numbers here. I just have to click on them, so it makes life a little bit easier. So I did want to show you guys one thing. I mean, it's kind of it for today, because I think the other class, we stopped on percentiles, so I won't cover that with you. I'll hold off on that. What I did want to show you was something I think is kind of cool that's related to statistics, so I feel okay showing this. So it was, I had someone in my one section asking me about this. It was just COVID positivity rate. CDC. Oh, I know why. It's because I'm not using Google. CDC. COVID positivity. I think it's this. Oh, it should take me right there. It's one of the first few links. I thought this is what I searched there. COVID positivity rate. Graph CDC. Oh, maybe I'm not going to be able to find it. I just looked at it the other day. That was the first link. What else would I have searched? COVID. Try by state. Here we go. I was wrong. It wasn't the CDC. That's why I'm getting it wrong. Here we go. This is what I want to show you, right? And I can't. It's a little more difficult for me to zoom in with this. I think what I should be. There we go. Okay. So I'm going to move myself, and we'll talk about this. So I thought this was relatively interesting, right? And it kind of there's things we'll talk about throughout the course that kind of relate to it. But anytime we hear, I hear a lot about COVID rates going up, but when people say rates, what they're typically talking about are the number of people testing positive, right? So if we look at the number of people testing positive, right, this is actually just this kind of darker orange line down here. So when you put that in scale, like a lot of the graphs you'll see is just that, and it looks like there's a lot more like swing to it. But when you put it into scale with how many tests that we've administered, right? So initially, right, this goes back to like April, the only people getting tested back then were people who were like, yeah, I definitely have some severe symptoms. So notice the positivity rate was like pretty high. I mean, 20%. So 1 out of every 5 people getting a test had COVID. But it's because most of the people going, the tests were so rare that if you got a test, it's because they were like, yeah, we really need to know, like, if this is what you have, like things are getting severe, So originally that rate was so high. Once we started getting more tests though, notice what starts happening to that positivity rate. It starts falling quite a bit, right? Now the number of cases, it's harder to see here, but the number of cases was dipping a little bit as well. And then once we got to kind of the start of July or kind of end of June, we noticed the positivity rate goes up, even though the number of tests are going up, more people started getting it. So this is alarming, right? Yes, the number of cases are going up, but also the percent of people getting tested is also going up, right? We're kind of like accounting for how many, because if I test 100 people, I'm not going to see as many cases if I test 100,000, right? That's it's just the way it's going to work. And so kind of noticed here, the number of tests have kind of like tapered off. But we're also seeing kind of now that these positivity rates are tapering off a little bit as well. So I thought that was relatively interesting. Allowed us to kind of think about, what statistic we actually want. Like, do I want to find the average positivity rate over this time, or do I want the average number of cases? Like, we need to think a little bit harder about just using the number of something, right? Usually, more often than not, a rate is going to be a little bit more useful information. And I did think this was interesting. So I just told you the story of the US, right? This is not looking as good. Let me see if I can. Is there like a save option I need to do? Here. Where was it? I want to show you Indiana. I was going to say, let me refresh this real quick. All right, now I'm going to try to go to Indiana. There we go. All right. So notice in Indiana, the positivity rate also dipped, but it's no longer like still on the decline. It's actually kind of increasing right now. Even though the number of cases, like especially like this must have been like when we started. I guarantee you this is like, yeah, right? Like look at that spike, right? So, you can kind of tell this is like a good example of like graphs, even like this can be pretty good representations of conveying a lot of data and all the information at once. But you kind of see where our positivity rate's still going up, which is not great, right? But yeah, you can play around with some of this, and hopefully as we talk about more statistics and start thinking about things a little bit different, we'll be able to pick up more information from even a simple little graph like this. Okay. All right. So I will. You should have everything you need to work through that Excel file. You should now, with the exception, I think, of like either the last question, maybe the last two questions, have everything you need to get through that Connect homework as well. Even on the last question, I think you can answer parts of it. Well, we haven't talked about covariances or correlation coefficients yet. We'll do that on Monday, and then you'll have everything you need to be able to kind of complete both those assignments. So due dates are still quite a ways off, but try to start working on those early, especially the Excel assignment, so we can not have last-minute questions, right? The way the office hours are going to be this semester, I used to get like several people and we do group stuff because everyone would wait till the last day or two. That's not going to be possible now. So, but maybe we could do it on Zoom with multiple people. That'd be fine. It's just try to get a start on them early. Okay. Also, I'll probably put an announcement for those of you who are on the Zoom today. I mean, tell me if I'm wrong on this, because if I am, I don't want to put this announcement out. But I know that some of you, I've seen the numbers go down. I would imagine that it's not the funnest thing to listen to. I could put an announcement, and I'm justified in saying that this sounds much clearer. Am I correct in that, or am I blowing that out of proportion? Did everybody already leave and nobody wants to? Yeah, correct. Yeah. Okay. So I mean, to me, it's a marked increase or improvement in the sound quality. So hopefully those of you in person will notice that as well when you're on the Zoom meeting. Okay. All right. Have a good weekend. I will see you guys some of you on Monday. Some of you won't see until Wednesday. Stay safe and enjoy your weekend.